My very first job, I insisted on not being what I would call a paper engineer. In the world of engineers, and technologists, technicians, and tradesmen, I noticed growing up with my father being a caller and then working in factories, etc., that engineers, for some reason, there was this hierarchy. I didn't believe in that. I really appreciated the trades. And I made it a point immediately after university that I would get to know them. I wanted to design systems that were very effective, not only financially in terms of energy, but in terms of maintenance, etc. I wanted to design really great systems. And the only way I could think of doing that was to become friends with the tradespeople if they would let. He said, follow me. He took me over to this large pipe, steel pipe, no insulation. He said, put your ear against this. And I did, and I could hear the liquid flowing through it. And he started to open this valve, and you could hear the liquid straining against the flow. And it got to this one place, and you could start hearing the vibrations in the valve chattering. And he said to me, that's called a pissed off valve. And he kept opening it. What you want to do is design so that it's very comfortable. And you got to that real sweet spot. He said, you design for here. And he taught me how to hear. That was the first thing out of the gate. He taught me so much. But that opened a wide variety of conversations with different tradespeople, controls specialists, steam fitters, hydronics especially, electrical people. Everything I could think of, I approached them the same way. And they were very kind and very generous with their time because a lot of them had come up through the same kind of ranks. I think I was very blessed early on coming up through, I think was the last generation. They didn't go to college, they didn't go to university. They learned from the ground up, working their way up through the parts department and just here's some tools and this is where you start. There's one older gentleman, he started high school and after about a month of that, he said, I'm not gonna. And he became an apprentice in the heavy electric industry, those big power lines that you see dotting the landscape. He became a business owner, very, very successful in a large firm, one of the most trusted companies in North America. And he came up through the trades. And I was fortunate enough that I kept running into people like that in their 60s, 70s, and 80s who were born in the 20s and 30s and 40s. By the time I got to them, most of them had 40, 50, some had 60 years experience. And they understood what it took to get from the very starting point. And they would just hand me the wrenches, hand me the welders, hand me the wire cutters. And I insisted that anything that I designed that I would work on, I'd be part of the crew. But that was the approach, taking hundreds and hundreds of years of these very insightful tradespeople and engineers and designers up to the highest levels, taking all of that into account in terms of a design structure, a product structure, and maintenance outlook, weather, et cetera, implementation, installation, all of it. I started out in the energy world, I would say modestly. Financially, it was the most successful, other than the entire country of Canada. But it was $247,000 in energy savings with a 47 business day payback. That's the quickest one I've ever done. And I remember looking at it, and it was the first time that I considered if I tried to create the same amount of energy using solar or wind or geothermal, what would it cost? And when I did the comparison, I was astonished. In every other situation, it would be millions of dollars. with a payback period that we'd never consider and a project that never would have went ahead. And here it cost an absolute fraction. And that was the day I started looking at what I call energy optimization. Energy optimization is where you take an existing system and you see opportunities that even the beginning system design engineer didn't consider. And you optimize it in a way that is more lucrative than anything the company is doing ever. One project I did for Maple Leaf Foods, for instance, you think about a massive plant is worth $1 billion, and there's hundreds and hundreds of employees, and the energy systems are extremely complicated. If you walk into a boardroom with a system optimization project that can easily return 100%. So it's 10 times more effective than anything they have in their entire portfolio of business. And that's why I call it energy optimization. Really at its foundation is a financial optimization in ways they can't possibly even consider because they're not trained to do that. And when I think of the Stingray, in terms of return on investment, at the worst case, it's 50%. In some cases, it'll be a matter of months. You can't get that. You can go to every Standard & Poor's 500 in the last 100 years. The average return from the largest corporations, the most bright, the best, has been around 10%. But I give full credit to these incredible tradesmen and some of the engineers I came across, and those the incredible men that took me under the wing, the last generation. I'll never forget them. There's a journey of trust that happens. They don't know you yet. And it really comes down to who have you worked with. They will not align with you unless you are the best. In engineering firms, it was top tier. So when you walked into a very large company, they looked at your portfolio, not only of your projects, but of your suppliers and your engineering service providers, et cetera. And they realized that you were worth considering. But after that, I would call it, they take you for a ride. And I'm making part of this discussion is because the people considering Stingray in the future globally now, they don't know me. So I'm giving them a glimpse of my past. Ingersoll Rand International. They're one of the largest companies of its sort. I think it's 16,000 people, billions of dollars in revenue, and they hired me to help a company that had billions of revenues and hundreds of engineers. But none of those companies had the experience that I did. So both those companies trusted me with their livelihoods and their reputation and their future. So that's where it all comes from. The credibility is everything. It goes to the very largest client I've ever had was the entire nation of Canada. Taking the design process that I learned through all of this and applying it to the entire country in terms of gasoline. On an energy side, we removed the anti-knock agent MMT out of gasoline, you immediately increased fuel performance by 10 to 30% over the life of a vehicle. And that is the height of energy design where you can save enormously. The payback period on good choice is almost immediate. The payback period is not even worth talking about when that was between $5 and $8 billion, but that was 20 years ago. So you think of the money. And that took about 6 months to design the political solution that gave them the ability to say yes. One big project I did actually local here, the day we turned it on, they had about 200 people outside, all of these tradespeople and engineers, because they didn't know if it was going to work. It was the first of its kind in the world. And we spent a good hour. It was an enormous system, very complicated in terms of thermal performance. And when it finally came to life, they all cheered and were jumping up and down, all these 40, 50, 60-year-old men, and celebrating the new life of this system. When new technologies come to the forefront, like it has with the Stingray, with the advent of carbon fiber rods and spectra fabric and the acceptance and new batteries like lithium ion, they allow you to progress. So it's never a complete eureka moment. It's more of a progression of great ideas and great people have come along, and culmination of opportunity that you kind of go, yeah, now I can take that next step.